Hello friends, and today's topic is a quick revision of nucleus, and we are going to discuss important topics on the nucleus, that is for your final exam purpose. So in this revision of a nucleus, we all know that in the nucleus there will be a number of protons will be present and the neutrons will be present, and electrons are the revolving around the nucleus. So here we are only focusing about the proton as well as the neutron. So this is a nucleus. I can take an example for a helium atom. So this helium atoms contain 2 protons as well as it contains 2 neutrons. So there will be 2 protons as well as there are 2 neutrons. So here total number of protons as well as the neutrons, we are calling it as a mass number. So the mass number is nothing but the sum of proton as well as the neutron numbers which are present at the nucleus. So this we are representing by a letter called A, alphabet letter A we are using. And there is one more term, that is atomic number. So this atomic number is nothing but a total number of protons present, at the nucleus. So this we are calling it as an atomic number, and this is denoted by letter Z. So if I take any x element, so that x element I am representing like this, and I will write a mass number at the top of this element, and in the bottom I will write an atomic number. So here there is a helium atom. So this helium I am writing it as a center, and in this helium atom there will be 2 protons as well as the 2 neutrons. So when we add, we are getting a total 4. So that 4 is nothing but a mass number, the sum of proton as well as the neutron number. So that is a mass number, and there are only 2 protons, so that I am writing here. So this is how we are representing the elements. And next topic is about a radius. So radius of the nucleus, whether it is remaining the same or it will be varies with respect to increase in the number of proton as well as the neutron in the nucleus. So volume of a nucleus, this volume of a nucleus which depends upon the number of protons as well as the neutrons present in the nucleus. Number of protons as well as the neutrons which are present at the nucleus. So if we increase the number of protons as well as the neutrons, the volume of this nucleus or the size of the nucleus goes on increases. So that all we agree. So what I can write, this volume of a nucleus is directly proportional to a total number of protons and neutrons present at the nucleus. So this is a basic thing. So this value I will represent by letter B, and this is directly proportional to total number of proton as well as the neutron present at the nucleus. So we all know that a total number of protons as well as the neutron, we are calling it as a mass number. So that is we are representing by letter called as a letter A. So now this is a nucleus. So this volume of a nucleus, so this is like a sphere. So volume of sphere is 4 by 3 pi r cube. So this is directly proportional to A. So if I take this r cube, so that if I take the r, then it will become a raised to 1 by 3. So from this, what I can conclude is that 4 by 3 pi is a constant and this is a constant of proportionality. So to remove all these things, what I will take is R naught a raised to 1 by 3. This R naught is nothing but empirical constant. So this R naught is nothing but empirical constant and its value is around 10 raised to minus 50 meter. So this is very small. So this is very small. So one thing what you have to remember is, if we increase the number of protons and the neutrons in the nucleus also, the radius is not changing. So the radius remains the same, because only minimal quantity of radius will be changing, but approximately the radius of all the nucleus which will comes under in this range 10 raised to minus 15 meter. If we take a helium, the helium atom contains mass number 4, and if we take uranium, which is having a mass number 235. So what a question will come is, see, in the helium only 4 proton as well as the neutrons are there, and in uranium 235 total 235 protons and neutrons are present. So because of that, the size of the uranium has to increase. But what is happening here is, this we are taking, that mass number is, we are taking cube root of A, and which is multiplying with this empirical constant, that value is 10 raised to minus 15 meter. So this is not going to affect the final result of radius of helium as well as the radius of the uranium. So almost all the elements are having the same radius, so which is approximately comes to 10 to the power minus 50 meter. So the next topic is, now we are going to discuss about the density. So here is also the same concept we are applying, means same logic we are applying. So the density formula, what we can write is mass by value. So density is mass by value. So we are going to calculate a density of the nucleus. So we want a total mass of the nucleus. So this I will rewrite again. So we want total mass of a nucleus divided by this value of a nucleus. See, here is a total mass of the nucleus. So how to calculate this total mass of the nucleus? So here we want to calculate total number of protons and the neutrons which are present, and we have to multiply their masses to that number. Then we will get the total mass of the nucleus. So this mass number, total mass is, which is depend upon this total mass, which is depend upon the mass number that we are representing by letter A. So the A is representing total number of the protons, and the neutrons which are present. So those things we are how to multiply their masses. So the mass of the proton and the neutron almost same. So they are very smaller quantity. So for that we are representing by letter 1 atomic mass unit. This 1 atomic mass unit, we can, in terms of kg, what we will get is 1.67 into 10 to the power minus 27 kg. So this 1 am is nothing but 1.67 into 10 to the power minus 27 kg. So next, volume of a nucleus, we know 4 by 3 pi r cube. So 4 by 3 pi r cube. So total number of proton as well as the neutron, what I can write is letter A, and that should multiply with the AMU, and 4 by 3, if 3 goes up and here it will come. So 4 into 5 r cube. So we know that r is equal to r naught a raised to 1 by 3. So this r cube becomes r raised to cube, r naught raised to cube raised to 3 by 3. So R cube equal to what we will get is R naught raised to Q. This 3 get cancelled, so we are getting a only. So instead of R cube, what I can write is R naught raised to Q and A. So this A get cancelled. So 3 1 AMU divided by 4 pi R naught cube. See, what I can tell you that a density of all the elements also remaining the same. Density of all the elements remaining the same. Sir, the mass number of elements will be increasing from helium to uranium. So the mass number is increasing, and what you told is radius is the same for all the elements. So whenever the mass is increasing, so density has to increase. And how you are mentioning and how you are telling that density remains the same. So that questions, if you are asking at that questions arise in your mind, see here what I am telling, density remains the same because, so whatever your question is absolutely right, because density depends upon the mass. So for a helium mass number will be 4, and for uranium it is 235. So this is increasing. So if mass is increasing, density has to increase. So whatever the questions coming in your mind, that is absolutely right. But here at a final equation, what we are getting is in the density, 3 is a constant term, 1 atomic mass unit is also constant term, 4 pi is constant, and R naught is also constant, empirical constant. So because of all these constant terms, and if we substitute all these values, what we will get is 10 raised to 70 kg per meter cube. So which is the same for all the elements, which is same for all the nuclei. So this is similar to water. So if we take a small drop of water, and if we take a water in a vessel, so here also what I can write, a density of water is 1000 kg per meter cube, and here also for a single drop of water also what we can write is 1000 kg per meter cube. So likewise all the elements are having the same density, and all the elements are having the almost same radius. So I hope you all understood these two concepts, and next comes we are going to discuss about the stability of the nucleus, so which is